Okay, welcome. If you missed class, I'm going to try to give you an abbreviated walkthrough of our lesson, and then you'll have a chance to go through the Desmos on your own. The problem is I won't be able to give you feedback in the moment, which is the kind of missed opportunity of missing class. Some things that you'll need today is you'll want to keep this in front of you, even when you go to Desmos, this chart, because this helps us to evaluate sine, cosine, and tangent of our common reference angles, 30, 45, and 60 degrees. Now, what we need to kind of solve these problems is really find what our reference angle is. So kind of walk these angles back into 30, 45, or 60, and identify which quadrant our original angle is in. So 7 pi over 6 is an angle in radians, which is really just a way to express how much of that circle in terms of its circumference this angle is kind of exposing or opening up to. So when I do 7 pi over 6, what I want to do is two things. I can multiply this by 180 over pi. That is our conversion from radians to degrees. The pi's will cancel out or factor. 7 times 180, and then I could divide it by 6. That's one way to convert. Another way to convert is think about this: 7 times pi over 6. I know pi over 6 from my chart over here is 30 degrees. So I really just have to do 7 times 30, which is 210 degrees. Now, this isn't my reference angle. In fact, this is just the same angle represented in degrees. So these two angles are the same, one in radians, one in degrees. Why I need that, or why it's helpful for me, is I can now visualize which quadrant this is in without having to use like common denominators and setting up a whole bunch of fractions. So 210, let's see, it's not between 90 and 180. It's between 180 and 270. So that's going to be down in this third quadrant over here. And remember that our quadrants are labeled ASTC. All students take calculus, which actually stands for all trig functions, the sine trig function, the tangent trig function, and the cosine trig function. So which quadrant is this in? This is in quadrant 3. And I'm even going to put in here why this is significant. Because if I look in quadrant 3, I get a T for tangent, which tells me the tangent of any angle in there is going to be positive. So tangent of 200, tangent of 250, tangent of 222, all of those angles in the third quadrant, if I take the tangent of that, I'll get a positive answer. But if I take sine or cosine of those will both be negative. So in this case, I'm taking the sine of some angle, 210. So therefore, my answer, whenever I get done here, is going to be a negative number. So my answer, I can already come down there and put a negative sign because I know whatever my fraction is going to be, it's going to be negative. Now I want to find my reference angle. So what is 210 kind of equal to in the first quadrant? Well, if this is 210 degrees, which I have kind of drawn here, we'd walk that back to 180, the x-axis. So we would do 210 minus 180 degrees. So we always want to go back to the x-axis. And in this case, when I go back to the x-axis, I get 30 degrees. Now, in these types of problems, it's actually kind of a hint if you look at that pi over 6. That pi over 6 is 30 degrees. A lot of times, that's actually just going to be your reference angle. So our reference angle here is 30 degrees. Why that is important is because whatever my answer is going to be negative. I'm just going to actually use sine now of 30 to find my answer instead of sine of 210. So if I look up here, I see sine of 30 degrees is 1/2. So my answer, putting those two things together, is negative 1/2. This is how I organize my thoughts. This is how I organize my work when I'm doing these. I think of quadrant and I think of reference angle. And then I put those two things together to see what my final answer would be. Okay. You can review this video. You can watch it again if you need to. But at this point, I would go to Desmos and I would take a 15-minute break to go to Desmos and answer questions 1, 2, 3, and 4 in that Desmos activity. And then come back to this video after you answer those 4 questions to move on to 5 and 6, and I'll show you why 5 and 6 are different. So pause your video and then come back. Hopefully you're coming back from pausing your video. If you are, you've noticed that questions 5 and 6 are a little bit different. They look like this. For number 5, if I were to go ahead and convert this into degrees, by multiplying by 180 over pi or 7 times 60, I would get 420 degrees. That's an issue because that number is kind of, in a way, too big. If I subtracted 180 from that, or 360, I might get something a little bit different. But well, I would want to subtract 360, but I guess what my point would be is this. If your angle is above 360, subtract 360 from it. The reason why that is the case, if I think about rotating around in a circle, I'm going to go 360 degrees. That'll get me all the way back to the start. If I go another 60 degrees, that's a total rotation of 420 degrees. So this is really, if I subtract 360, that's one full rotation plus an additional 60 degrees. So anytime I have an angle bigger than 360, I can subtract 360 to work this back into a normal problem. Now I might still have to find my reference angle by subtracting another 180, right? If that angle isn't in the first quadrant, I might have to do some subtraction still. But in this case, when I subtracted, I got 60, so there's no additional work needed. So my quadrant is quadrant 1 because that angle is going to be between 0 and 90, which means everything is positive there. Remember, that is an A there, so all positive. So my answer is going to be positive, right? And now I just want to know what my reference angle is. I don't need to do any work here. My angle is already between 0 and 90, so my reference angle is already 60. So now I got to find the cosine of 60, which is still 1/2, and this time it's a positive 1/2. So if you get an angle larger than 360, subtract 360 and then just restart your process, just like what we were doing before. Another example of that, let me just make up an example on the spot here. So let me just cross this out, and let's say the sine of, let's say, -3 pi over 4. If you have negative angles, we can just kind of multiply like we normally would. And if I multiplied like we normally would and converted, I would get -135. Oops, 135 degrees. And that's a negative, right? Now, that doesn't mean our answer is negative. That just means when we spin around our circle as far as our angle goes, instead of going 135 degrees this way, we're going 135 degrees the other way. And our angle is going to be pointing down in this direction. So a -135 is going backwards 135 degrees. If that's hard to envision exactly where that's going to be, we once again, instead of subtracting 360, we can add 360 to this. And then it'll tell us exactly what that angle is, but the positive version of that angle. So if I add 360 to this, I get 225 degrees. That's because if I were to do my angle in a positive direction, like we normally would be used to, I'd get 225. So what quadrant is this in? Quadrant 3. It was hard to tell, right? -135, what quadrant that was in. So I added 360 to turn it into a positive because -135 and positive 225 are in the same place. What does that tell us about our answer for sine? Well, let's see. We have A, S, T, C. Once again, that third quadrant is T for tangent. So since we're talking about sine, our answer is going to be negative again. I can come down to my answer and put a negative sign in there. And my reference angle is going to be found as I did before. I can look at that pi over 4 as a huge hint, or I can subtract 180, and my reference angle this time is going to be 45 degrees. So we'll take sine of 45, radical 2 over 2, and it's going to be negative because of the quadrant. So now you can go and finish questions 5 and 6 in Desmos and submit those for a grade. Thank you for tuning in, and I'll see you guys in class soon.